Hello, class. I'm going to go over Chapter 6, Section 2 for statistics, the applications of the normal distribution. So we're looking at story problems, applications, and we're going to be using ideas from 6.1. However, the numbers that are originally given have to be transformed by using this formula so that we can use ideas from 6.1. So just keep that in mind. Also on the test, you want to learn to draw your picture of your standard normal distribution graph and plot like the m, the mu, the mean, the standard deviation, your area, and or your z, right? Your x, as you'll see in the story in these story problems that turn into z's. um, and the first couple of graphs and the problems, they kind of help you with the pictures. So in the first couple of problems, they do help with that. But then the last page, you could see it's totally blank. And so you want to draw that out. There are going to be about, I think, 3 problems that I'm going to do from the ebook that I'm going to go ahead and show you as well. And these pages, I'm not going to make use of 150 and 151. I usually don't have a need to use 150 and 151. I think it's just supplemental and we don't need that information for what we're working on. Okay. All right. So if we look at what it says, it's got, some vocabulary at the top for section 6.2. So it says that the standard normal distribution curve can be used to solve a wide variety of practical problems. The only requirement is that the variable be normally distributed, approximately normally distributed. For all the problems presented in this chapter, and especially like this section 6.2, you can assume that the variable is normally or approximately normally distributed. And that's why we can apply ideas from section 6.1. So it says to solve problems by using the standard normal distribution, transform. That's going to be really important. You can't forget to do that. Transform the original variable to a standard normal distribution variable by using this formula. So this formula, you've seen this first in chapter 3. And then when I was talking about 6.1, I brought that up again. And now, in chapter 3, they use the X bar for mean and they use S for standard deviation. Well, here we're using Greek letters for standard deviation, sigma, and the mean we're using mu. And the value, they're talking about your data value, which we're still calling x. Okay. And they always forget to put the parentheses. This is important. You don't want to forget to write the parentheses, because if you do forget in your calculator, it can throw you off and give you incorrect answers. So be careful with that. And um, for some of the problems that we're working with towards the end, I believe the last page on 148, I believe, you'll be trying to find the x. And so because of that, I'm going to remind you, just like I did earlier when we talked about this formula, if I wanted to solve this formula for x, do that here so that we can use that later on. Basically, you would write this formula, you would put this over 1, and then I would advise you to cross multiply. And so z times sigma is z times sigma, and 1 times this quantity, x minus mu. Remember, 1 times anything is itself, and uniform you're doing distributive property, 1 times x, 1 times a negative mu. So basically we have z times sigma is equal to x minus mu. And remember, we're trying to solve this for x. So to solve for the x, we want to isolate x, get x by itself. So I'm going to add mu to both sides. And then the mu's cancel out. They 0, give you 0 there. And so you're left with x. And so you have Z times sigma plus mu. So just keep it on that formula and we'll make use of that later on as we need it. We won't need it for this first problem here, but it's just keep an eye on that formula, okay? That's where it's derived from when we use it, okay? So the first example, 6-6 says liters of blood. So an adult has on average 5.2 liters of blood. Okay, the word average, that's a mean. So for us, that's our mu. So that's a keyword. So you can see in the picture they draw the standard normal and the mean is in the middle here. So I'm going to put a little mu here. This is setting mu is equal to 5.2. Um, Assume the variable is normally distributed and has a standard deviation of 3/10. So usually your teacher writes it to the side. I usually have a tendency to put on the right side or you can put on the left side, but I put it somewhere nearby. And they want you to find the percentage of people who have less than 5.4 liters of blood in their system. So this is also a keyword, less than 5.4. That's how they know to shade this to the left. And 5.4 is drawn on this side because 5.4 has to be on the right-hand side of the mean 5.2 because, you know, it goes as you move to the right, gets larger and larger. So 5.2, 5.4. And it's also on a positive side, right? So it's going to be on the right side as opposed to on the left side. And then you see how they shade everything to the right. And we actually want to find the area here. We want to find this area. That's our unknown. And it says find the percentage. What happens is you would find the area and then you would multiply by 100% to find the percentage, okay? And so and what we're doing is we're finding the area underneath the curve. Find the area under the curve. Okay. And a lot of times too, they'll ask you to find the probability. Okay. All right. So notice here also this 5.4. This is called X in this section here. Okay. And so I want you to note that that um, that mu is not equal to 0 yet, that sigma is not equal to 1 yet, and I want you to notice that this is an x and not yet a z until we transform it. So the way to transform that is to go ahead and use your formula at the top, and we're going to use this. So we're not ready for this. We don't need this formula yet, but this is the one we need. We need to find out what z is. So we want to use z is equal to x minus mean divided by sigma. And when you substitute, um, x is 5.4 minus your mean is 5.2. And then when you divide it by sigma, remember sigma is 0.3. And so when you type that in on your calculator, parenthesis 5.4, take away 5.2, close parenthesis, divided by zero 0.3, you should get a repeating decimal of a lot of repeating sixes. Now, I'm going to just put dot, dot, dot here because this is a z. Remember, z's you want to round to the nearest hundreds. Z's are supposed to be rounded to nearest hundreds. And so this is your hundreds place, tens, hundreds, the 6 right here. Then you look at the number to the right. Is this 5 or more? Yep. So add 1 to the 6 and you have about 0.67. Okay, and that's your Z. So now notice this new picture that's drawn here. Notice now how this has changed from 5.2 to 0 because we've run that through the formula and we've transformed it. And now also here, notice how your teacher is writing sigma as 1, no longer zero point 0.3. And this is important here. See this? Now this is your Z. Because we ran it through the formula, we transformed it. This is no longer 5.4. This is Z. So this is very important. And we're still working on this, trying to find the area. Okay. But now we can apply ideas from section 6.1. So in 6.1, we did the table first, and then I did the calculator. So I'll do the same thing here. I have to show you both ways. And so when you write this up, I'm going to start with probability. And I'm going to start first. Originally, the way it was given is we had an X that was less than 5.4. We're trying to find this area, and it was an X that was less than 5.4. And then we ran it through the formula and we transformed it. And then now we're trying to find the probability, but it's no longer an X. Now it's a Z that's less than, and now it's no longer 5.4, it's less than 67 hundredths, okay, from here, right? And then this is the easiest scenario when you find area to the left. That's the easiest scenario. And so we're going to use the table first. So when we use a table, remember you're trying to look up, you look up the first two numbers, this 0.6, and then you remember we have a 0 here, remember, and then the last digit is 7, remember? So that if I were to add those two values, if I were to add 0.6 plus 0.07, you see how that gives you 0.67, right? So we did that for 6.1. Okay, and now I'm going to use a table. And I want, see, it's on the positive side. See, it's on the positive side. So you want to get your positive side of Z. And I like to use my two rulers. And I'm looking at 0.6. And I want the positive side. Here's the positive side, as opposed to the negative side. You want the positive side because it's on the right side of 0, not on the left side of 0. So you want the positive side. So it's 0.6, which you see it right here. See that right there? 0.6. And then the rest of it was, what was the rest of it? 0.07. So here we go right here. There it is. So see that number right there? See, so you have 0.6 and then see 0.07. See that number? 0.7486. 0.7486. Okay, so can you process that? Go ahead and process that. And that's what we need, okay? And this is the simplest scenario. There's nothing else that's needed here. No larger area minus smaller area, no subtractions from 1, no subtractions from 0.5. This is the easiest scenario when the areas are ready to the left of the curve. And so then that way, now we can just put that in here. So this area is 0.7486. Now, the thing is that they did want the percentage. This is the probability, this is the area, but they did tell you to find the percentage. So percentage means you just have to take that answer and multiply it times 100%. So 0.7486 times 100% is 74.86%. And they didn't tell us what to round to. I don't know, is the nearest whole or the nearest tens or the hundreds. So I'll just leave it like that. But they just said percentage. They didn't say like whole percent or round to 10. So I'm gonna leave it like that. Okay, now I'm gonna go back and you do this again, but now with the calculator. And I'm gonna do it at the top of your page. And so this part, I'll write this down again, and then I'm gonna use a TI-84. So come back at the top, and I'm using a TI-84. Okay, and so we have let's see, probability that X is less than 5.4 is equal to probability that Z is less than 0.67 equals. So remember, we're using two normal CDF, lower bound, upper bound, mu, and sigma. So this is equal to normal CDF. Now remember, lower bound, remember we read graphs from left to right. So remember, we're reading this graph from left to right. So what you see on the left is negative infinity. And negative infinity can be represented either by 10,000 or, remember, negative 1 e to the 99. And if you're going to use the negative 1 e 99, you've got to make use of the second and the comma key, because that's where that is at. Okay, so either one, it's a negative infinity, and you read the graph and then you stop here. So this 0.67, that's your upper bound. That's your upper bound. Okay, so you read it from left to right, lower bound, upper bound. And we don't even look at this anymore. Forget about that. Okay, so we have, you can choose. You can write negative 10,000, or you can do the negative 1 E99. Okay, and then upper bound is 0.67, and then mu is 0 and sigma is 1, because we transformed that already. Okay, and so now when you use your second vars, right, second vars, and you want number 2, and the lower bound, you have a choice. See, I already have negative 1 E99. If you're going to do that, you type the negative down here, negative 1. So you type negative 1, and then second comma's right on top of the 7. So it's comma, see, and then 99. Or you can do negative 10,000, negative 10,000. So one or the other. Okay, and then hit return 0.67, and then see 0 and 1. Okay. All right. Okay. So now this gives us 0.7485711176. And remember, this is an area underneath the curve. Remember, areas underneath the curve. And I think last time I had you write this down on one side of your sheet, right? Didn't I have you write this down on your sheet? The z-score is recorded to the hundredths place value, where the area is recorded to the 10,000ths place value. Okay. So I'm going to round this to the 10,000ths, tenths, hundredths, thousandths, 10,000ths. And then I look at the neighbor to the right. Is that 5 or more? Yep, it's a 7. So I'm going to add 1 to that. So 0.7486. And then they wanted a percentage. So this is where I'll multiply that times 100%. So 0.7486 times 100 is 74.86%. And you can see that matches our work from the bottom down there. Okay. So you see how I had to use ideas from 6.1. Okay. And then you have to learn how to set up your tables. You'll have to do that for your tests. Now, I won't expect you to, you know how I found the probability using the table and then also using the calculator. So I don't expect you to do both on the test, but I will specify, I need you to demonstrate both. So I need you to, I'll specify on the test, this one I want you to use the table. This one I want you to use the calculator. Okay, so to get the full credit, you should show the method that's requested of you. Most of the time when you do it both ways, majority of the time it come out the same answer, but there are some special cases where it can differ off by a digit, like in the hundreds place or off by a digit. And so that's why, if the computers in your homework, if it says use a table, you should use a table. If it says use a calculator, then you should use the calculator, because there are some special circumstances where things vary just a little bit, and then it won't recognize the answer because it's off, and if you didn't follow directions. But we want you to know both methods. Okay. All right. So um, second problem. This one, 6-7. This is on page 148, 148 of your workbook. Okay, this one is a sandwich problem. See how this is sandwich in between there? Okay, so this one says newspaper recycling, that each month an American household generates an average. See, there's your mean of 28 pounds of newspaper for garbage or recycling. Okay, so this is 28 and this is pounds. And this is your mu, because it says that's your average, right? So it's a keyword. Assume the variable is approximately normally distributed and the standard deviation is 2 pounds. Okay. And you always want to make sure these are the same units. I think on your homework, there's a few problems, I think one or two problems where they're not the same units. I think there's a problem where you have dollars, like money. One says so many dollars, and then the other one has so many cents. So you cannot work a problem where you have different units. So you should, like on that problem that has money and cents, you should make them all pennies, make them all into change in all pennies. And this one's good because they're both pounds, but if you had ounces and pounds, if you had ounces and pounds, you can't work with numbers and have different units, so you have to make them all the same unit. So usually we make it the smaller unit. So if you have pounds and ounces, you put them all in ounces. If you have dollars and cents, you put them all in the cents, for example. If a household is selected at random, find the probability of it generating between, here's a keyword, between 27 and 31 pounds per month. Okay, so good. They're all in pounds. So that's good. These are all in pounds. Okay. Um, yeah, and I wish we did a better job with our recycling, right? And our garbage. I wish that were more organized in the cities and the rural areas, and then wherever the garbage goes, I wish it would handle that better, right? Instead of just piling up somewhere. Okay, let's see. So, and so they said in between, right? So that's why this is shaded in between that. And when they put these, it doesn't really matter. These don't have to be exactly accurate, but 27 is going to be to the left of 28, and that 31 is going to be to the right. So you do know that this has to be similar, right? It has to fall within the correct regions here, right? So 27 first, the mean, 28, and then 31. So it does have to reflect that correctly. All right. Now the thing is that we need to find um, not just not just one z, but two z's. We need to find both of these. Um, we need to find the area. We need to find the area. So area is equal to question mark, right? We need to find that area, but we also need to find our z's, okay? And so I'm going to make a note somewhere here and say that to find the z's, to find like the z sub 1 and to find the z sub 2, you're going to run it through the formula. And you will have to use the formula twice, not just once like in the other problem, because you have two z's. Okay. And so we have z sub 1 is equal to parenthesis x sub 1 minus mu divided by sigma. And I'm going to decide on this. I'm going to make this one x sub 1, and then I'm going to make this one x sub 2. So just kind of in order, 1, 2, okay, left to right. And when I do my substitutions, I have 27 minus 31. No, 27 minus the mean. What is the mean? The mean is 28. All over sigma, which is 2. Let's see. Okay, so when I plug that into the calculator, parenthesis 27 minus 28, close parenthesis, divided by 2. It looks like it gives us a negative 0.5. And so I'm going to draw a new picture. You see how they didn't put the new picture? So they want you to draw your new picture. So your new picture would look kind of like this. Put the me in the middle here. And then I'm going to do this. And so this is z sub 1, which z sub 1 is negative 0.5. And then we're going to find z sub 2 in a little bit. We're trying to find this area in here. Okay, so now I'm going to do this again. Z sub 2 is equal to x sub 2 minus mu divided by sigma. And x sub 2 is 31 minus mu, which is 28, divided by sigma, which was 2. Okay, so let's type that in. Okay, so parenthesis 31 minus 28, close parenthesis, divided by 2. Looks like that gives us 1.5. Okay, so then I have over here 1.5. Okay. All right. So now we're going to find a probability. And this is the scenario where they're trapped or sandwiched in between. Remember, there's like 3 scenarios. This is the one where they're trapped in between. The first one we did was the easiest one when the area is immediately to the left. Okay. This one, it's trapped in between. So when I set it up first, when we set it up first, it was X's stuck between 27 and 31. So kind of like this with X's. And then we ran it through the formula to kick out a z. So then we had then negative zero point 0.5, and this is now a z and 1.5. So we ran it through to kick out some z's, and now the z's are between negative 0.5 and 1.5. Okay, and I'm going to use the tables first. And when I use the tables, remember I have to do the larger area, take away the smaller area. So the larger area looks like this. Z is less than this one, 1.5. This is a larger area from here, all of this. And then you're taking away the smaller area. So probability of Z is less than the smaller one, negative zero point 0.5. Okay, so you're doing this larger area minus the smaller area, and that's going to leave you left with this. Okay, so you have this whole larger area, and then you're taking away this smaller area. So then now all you're left with is now you're going to be left with this orange. That's going to be left with the orange now. Okay. So and we're going to do the table first. So in the table you have okay, remember it's 1.5 and then this is 0.00 because this is 1.5. And then this one is negative 0.5 and then 0.00. Okay. So do you remember that? Remember that we use the first two, remember like here? Remember here, we use the first two digits, 0.6, and then we have a 0, and then we add the last digit 7. That's kind of what's happening here. So the first two digits are 1.5. First two digits are negative 0.5. And then you have a 0, and then that last digit. It's just that this last digit is like a 0 back here. And that one also has a 0 back there. So it ends up being 0, 0 here. And so I have the 1.5. So when I go to my chart, 1.5, go to my positive chart, 1.50. And you see 0, 0, see is in the front. So 1.5 is right here. And if I use my two rulers, so see that 0.9332. 0.9332. 0.9332. All right. And then we're going to take away the other one, negative 0.5. Negative 0.5. So I'm going to go to the negative side. Negative 0.5. And then it's 0, 0. So there's a negative 0.5. And then remember 0, 0. See, it's right there in the front. And so it's this number right here. Which is 0.3085. 0.3085. Okay. And what you're going to do is you're going to subtract those. So if I subtract those, okay. So we have 0.9332 minus 0.3085, right? So this one was 0.9332. That was the larger area minus the smaller area, 0.3085. And that gives us 0.6247. Okay. Okay, now I'm going to use the graphing calculator, and that's this area in here. That's this area here. So this area in here ends up being that. Six 247, because that's this little area in here. Now, if I use the calculator, I'm going to go up to the top and use the calculator. Okay, so the first two lines would be the same. This start off with x's, trap between 27 and 31. You ran it through this formula, z formula, and then now it's a z, and it was trapped between these two, negative 0.5 and 1.5. Okay, I'll write that down. Okay, I'm going to use the norm. So the two normal CDF. Lower bound, upper bound, mu, and sigma. All right. And then when I do my substitutions, remember we regress from left to right. Remember, you're not looking at this one anymore. You're looking at this one. And you regress from left to right. So you see this is your lower bound. This is your lower bound. And then you see it stops right here. This is your upper bound. Lower bound, upper bound. Okay. So you have negative 0.5 all the way to 1.5. So this is normal CDF. Lower bound is negative 0.5. Upper bound is 1.5. Mu is 0 and sigma is 1. Okay. All right. So when I do my calculator, remember it's second bars. So it's second bars. Second bars right here, bars. And you want number 2. And lower bound is negative 0.5. Enter. Upper bound is 1.5. Enter. Mu is 0. Sigma is 1. Okay. And then hit enter. Okay. And remember, there's more digits back there, but you have to round to the 10,000s, right? 4 decimal places. Tens, hundreds, thousands, 10,000. So I highlight that 6, and you look at the number to the right. Is that 5 or more? Yep. So you're going to add 1 to it. So we have 0.6247. And you see that matches. That matches to what we had at the bottom, remember? That matches this. Okay, now the second problem, I'll do this. I mean, the third one, I'll do this one, but I wish I had given you one where they refine the area to the left, because this one kind of repeats the first one, except that it says here that you have, if 500 uh, personal computers are selected, approximately how many will use less than 106 watts of power. So the thing is that when you find the probability, you'll have to multiply it by 500. So that's how it is different from the first one. But as far as the area to the left, this is the simplest when you're finding already area to the left. And so it says that amount of electricity used by a PC. So a desktop PC use 1,200 watts of electricity per hour based on 4 hours of use per day. The variable approximately normally distributed, and the standard deviation is 6. Okay, so standard deviation is 6. And then this is, see, they already have this drawn up for you, but that's your mu. It's 120. So I guess 4 hours per day. I guess if you do like 30 days in a month, 4 times 30 is like 120. So that's kind of where that's coming. And they also said 420 watts here. And they were just breaking at 4 hours of use per day. And even though this one didn't have the keyword, like we're used to seeing average or mean, this one doesn't have that. But think about it, they're averaging 4 hours of use per day. So that's kind of related there. That's your mean. Um, and then standard deviation was 6. And then if 500 PCs are selected, approximately how many will use, there's your keyword, less than 106 watts. So you see how they're shading to the left of that. And so this is your X here. That's your X. Okay. So again, we're going to have to transform that. So we'll have to use Z. Here's the formula, X minus mu divided by sigma. X is 106. Minus your mean, which was 120, divided by sigma, which is 6. Excuse me. So use the calculator for that. Parenthesis 106 minus 120, close parenthesis, divided by 6. And then it's a negative 2.3 repeating. And I'm not going to write all those threes. I'll do dot, dot, dot. But remember Z's have to be written to there's hundreds. Area is 10,000s. Z's is hundreds. So you look at the number to the right. Is that 5 or more? No. So it looks like it's negative 2.33. Okay. For your Z. Okay. And then they also didn't draw a new picture for us. So we'll have to draw that ourselves. Okay. And so now your mean is 0 and your sigma is 1. And then this is kind of looking like this. Now this is your Z, and your Z is a negative 2.33. Okay. So then we set this up. So probably first it was X's, right? X was less than 106, right? And then we ran it through the formula, and now we have Z less than negative 2.3. And then again, the table is, this is the easiest case because it's already area to the left. So when we use the table first, and what we're looking up, remember, is negative 2.3. And then remember, this part's going to be 0, 3. And of course, if this is negative, yeah, this is understood to be negative 2. And again, if you were to check that, if you were to add both of those, negative 2.3 plus negative 0.03, that should give you negative 2.33, okay? Check that. And then when you look that up on your table, you're on the negative 2.3. Negative 2.3. And then negative 0.03. So the chart doesn't have any negatives. I wrote these little negatives in, but you know, if the z's are negative, these are also negative. The other ones, they're positive on the other sheet. Okay, and so we're looking up, I say negative 0.03. See that? See that number right there? 0.0099. See the negative 2.3, and then see the negative 0.03. So it's 0.0099. 0.0099. All right. Okay, so then all we have to do now is just multiply it times 500, because this would be for one. This would be for one PC. But if 5 of them are selected, then you multiply that by 500 PCs. 0.0099 times 500 is 4.95, which would be about 5. 5 will use less than 106 watts of power. Okay, now what I'm going to do at the bottom is I'm going to use a calculator. So this part will be the same. But then when I use my calculator, I'm going to use 2 normal CDF, lower bound, upper bound, mu, and sigma. And then I'm going to do the substitutions. So let's see, normal CDF. So when you read your graph from left to right, and remember we're reading this one, don't look at this one anymore. We're looking at this new one. You got that negative infinity. So remember, this could be, you can type in negative 10,000, or you can type in negative 1E99, but you want to use that here. So I'll use the negative 1E99 because I think I used negative, I think I used negative 10,000 last time. So I'll use the negative 1E99 now. So you're reading it from left to right. So this is your lower bound, whereas this one over here, this is your upper bound. Negative 2.33. Mu is 0 and sigma is 1. And it's a second bars. Okay, so second bars, number 2. Okay, and I'm going to do the negative 1, second comma, which is on top of number 7. And it gives you your E, and then do 99. And then it was from the negative 1E99 to negative 2.33. Remember to negative. It's shaded from left to right. It stopped at negative 2.33. Mu is 0, sigma is 1. That should look familiar, right? Does it look familiar to this? Okay. And of course, they have more detail. I'm going to round it to the tens, 100,000, 10,000. And is this 5 or more? Nope. Okay, then I want to do a problem where I was going to show you the area to the left because we did the easiest type area to the left, and then we did one that was sandwiched, right? So I actually want to do, I meant to say I'm going to do one where the area is to the right of the curve. So I actually looked at the ebook. And let me get some paper out. And I wanted to do the one from the ebook, which I think it was, what number was that? Is that 4B? Let's see. Let me see. Let me get my questions out. I have my questions here. Let me just a second. Let's see. Give me a second. Hang on. Okay, that'd be fine. It's a part B. I didn't want to do part A and B. I was thinking, okay, do I have to do part A and B? I don't think I have to, but this is what the problem looks like. This is from your ebook. And these are just the little answers here. Double check that. And so I'm going to do the second part. This is the national average SAT score for the verbal and math is 1,028. Okay, so with that, the average, that means you can draw this here. And your mean is 1,028. If we assume a normal distribution with sigma equals to 92, what is the 90th percentile score? Okay. And then it says, what is the probability that a randomly selected score exceeds 1200? So that's what I wanted to show you. If a score were to exceed 1200, well, 1200 has to be somewhere on this side because mu is already 1028. So if I draw this like maybe like right here, and exceeds means shaped this way. And so this would be an X. This is not Z yet. This is an X because this is not 0. So this cannot be a Z yet. This is not 0. And this is not 1. So, and it's 1200 because it says, what is what is the probability that a randomly selected score exceeds 1200? And so we're looking for the area. It asks what's the probability, and that's another way of saying what's the area. Okay. And so that's what I want to show you, because in your book here, the workbook, they did two that were area to the left, right? Area to the left. And then this one was area to the left. And then they did one that was sandwiched, but they didn't show one where you had area to the right. And that's why I wanted to do this one, because this one had an area to the right of that. Okay. All right. So then, and let me just put the question at the top then. Let me write this down. So I had SAT scores, and this looks like number 4 from your ebook. And I don't know if everybody has the same page. I have 330 from your text, and this is from section 6.2. And it says the national average SAT scores and this is for verbal and math is 1028 if we assume a normal distribution with sigma equaling 92. They were asking what's the 90th percentile. And then what we're showing is the second one. They were asking what is the probability that a randomly selected score exceeds 1200. And that's why I drew it like that. Okay. Okay, so what we'll have to do is we'll have to run it through the Z. So I have to transform it. So transform to find Z. So transform X to find your Z. So the formula is X minus mu divided by sigma, and X is 1200 and mu is 1028, and we divide it by sigma, that's 92. Okay, so I type that in. 1200 take away 1028, close parenthesis, divided by 92. So don't forget your parentheses. 186,956, and a whole bunch of other digits. But remember, Z's are rounded to nearest hundreds. So I have to round this to the hundreds place. And look at the number to the right. Is that 5 or more? Yep, that's a 9. So 0.1.87. Okay. And that's your Z. Okay. And we only need to find one Z. When they're sandwiched, we have to find two Z's. This one, you only need to find one Z. All right. So then now when you set up your probability, so we have probability that x. Let's see how we're going to write this up. Because we got to find area to the left of the curve, right? We have to subtract. Okay, so first we have that it was x's, right? First it was x's that it was greater than, let's see, that it was greater than 1200. And then we transfer it in through the formula, and then we have x, no, z became a z, and then it was greater than 1.87. Oh, and then I need a new picture too. I didn't draw a new picture. My new picture, I'll put it right here. So here's mean. Now mean is 0. Now sigma is 1, right, in the new picture. And z is 1.87. Okay. Now the thing is to find this area, we need, like, we can't find areas to the left of the curve. We can't find areas to the right of the curve. We need to find this area to the left of the curve, right? So we have to subtract. This whole area underneath the curve is 1. So this is going to equal 1 minus. And let me make sure how if I look at my 6.1, let me look at my 6.1 real quick. Let's see. Let me find a picture from 6.1. Yeah, we're doing good. We're doing good. So I was just like I was looking at this picture here, for example, in 6.1. See this pink? We're trying to find this. See, already got the Z, see? And yeah, we subtracted from one area, and the curve is 1. That's looking for this part. Yeah, so we do 1 minus, probably Z is less than that. Okay, so just looking, making sure I'm consistent with that. So then this would be, for us, this is going to be area to the right, 1.87. This is going to be 1 minus probability z is less than 1.87. So you're trying to do the whole area of the curve is 1, and you're trying to take this out, yank this out. So you're trying to yank this out, subtract this out. And then you'd be just left with that. Okay. So then when we look this up on the table, this is 1.8, and then this is 0.07, correct? First two, and then 0.0, and then the last digit. And this is on the positive side. So if I go to positive C, 1.8, and then it was, what did I say? Was it 7.07? Okay, and see this, see that number right there? See a number right there? 9693. See that? 9693. 9693. 9693. Okay, so then I have 1 minus 0.9693. 1 take away 0.9693 0307. Okay. And that's what they want. They want the area. And if I go back to my problem, let's see. I'll go back to the problem and show you that. See right there? See that? 0.0307. This is second one is there's two parts. This is the answer to the second part. And that's what I was doing, the second part, because I wanted to show you. They had the first problem in their workbook had area to the left, and then we had one that the second was sandwiched in the middle. And then I want to show you one where the area is to the left here. So there's that. Okay. And a lot of these in your workbook, uh, I mean, these from your ebook, I did work several others, and I have ebook pages in your test 3 module as PDFs, and pictures like the PDF save and then the ebook pages save. And I just kept them in there because that was like before we had the workbooks. Before now we have the workbooks and they picked out problems. Um, and so, but this was before we had the workbooks. We would do problems out of the ebook. I mean, out of the the e-textbook, right? And then these problems, majority of the ones from your workbook, I mean, they also come from your ebook and they come from the intro and the textbook and the reading also, whatnot. Anyhow, so but they're in there if you want to go back and review other examples, you can, and that will also resemble your homework because this might be a section where you would want to go into tutoring for math world or you want to review some extra notes. This would probably be a good section for you to do that in this 6.2 section. All right. Okay. So now this is using the table, right? This was using the table. Now I'm going to do it again using the TI 84. Okay, so first we started with x was greater than 1,200. And then we ran it through the formula and it became a z. And the error we're looking for was greater than 1.87. Okay. And then we're going to use the calculator on this one, which is going to be 2 normal CDF, lower bound, upper bound, mu, and sigma. And when we regress from left to right, uh, we're reading uh, we're reading this part left to right here. And so this is your lower bound, 1.87. And then this is shaded forever in this direction. This is your infinity, which is 10,000 or 1 e to the 99. So you can choose whichever you want, 10,000 or 1e99. And then mu is 0 and sigma is 1. And you're using second vars. So then that would give us second vars, number 2. Lower bound is 1.87. Upper bound is 10,000. Mu is 0, sigma is 1. Let me get this. And there's a whole bunch of other digits, but we just need areas, 10,000s, tens, 100,000s, 10,000s. So you look at the number to the right. Is that 5 or more? Nope, it's a 4. So it stays 0.0387. Oh, and I wrote that down. I'm sorry, it's just 0.0307. Yeah, I saw this. Like, why isn't it the same? Sometimes, I mean, majority of the time it's the same. Sometimes it might be off by just one digit at the end. But yeah, I just copied it down wrong. Okay. All right. Okay, now we're going to go to the next page in your ebook. Let me see. There might be one more I want to do next. Let's see, before I go to that last part. Let me just see. Hmm. Yeah, let's see. I think I need to do this one before I move on to that last page. Yeah, because okay, so this one I'm gonna do. The first part is gonna be repetitive because it's kind of be area to the left of the curve. But the thing is that um, after we find our z, they don't want you to find the probability like we've been doing. They actually want you to find sigma, and that's why it's a little bit different. So I better show you that because I think there's one on your homework. So let me show you one like that because I didn't see that in the workbook. So let me show you that one. Let's see. Okay, so in your, this is 12 in your ebook. Let me write that down. Let me read it. Let me show you number 12. Let me show you. This also has a practice with the units. The units are different here, and I think there's one in your homework like that. You have to fix your units. See how they have cents and then dollar sign? We're going to change it all to just leave it in cents. The average retail price of gasoline, all types, for the first half of 2009 was 236 and 5/10 cents. Okay, so that's average is the mean, right? So 236.5. This is cents. And it said, let me see, it said, I'm gonna put my glasses on. I'm sleepy. Okay, and then it says, what would the standard deviation have to be in order for there to be a 15% probability that a gallon of gas costs less than $2. Okay. All right. All right. So probability is the area underneath the curve, area underneath the curve. So that's, and it says 50%, be a 50% probability that a gasoline gas costs less than $2, less than $2. Okay. So that's why, you know, this keyword less than $2. Now, the thing is, this is, you need the same units. So my question to you is, how many pennies are in $2? So you know 100 pennies makes $1. So there would be 200 pennies. 200 pennies because $1 equals 100 pennies. So $2 makes it 200 pennies. So and 200 is somewhere on this side. See, this is 236. So this is somewhere on this side. And this is x equals 200, and it's cents. And it's not a z yet. It's not a z because this is not 0. Okay. And the thing is, you don't know what sigma is. We got to find sigma. That's what they said. They said to find sigma. And so this is reflective of the 15%, which is 0.15. You know, 15%, this is 15 over 100. Percent is parts per 100. So 15 divided by 100 is 0.15. Okay. And so this is 15 divided by 100 is 0.15. This is your area. Okay, on this side. All right. Okay, so process that, process that. Okay, so yeah, so we've got to, you remember we have to, you have to uh, run it through our, let's see here, run it through your Z. Well, we run it, if we look at our Z, we have Z is equal to X minus mu divided by sigma. And we know what X is, and we know what mu is. But see, we don't know what sigma is, and we don't know what Z is. We don't know what Z is, so we've got to find Z. We've got to find our Z. Okay, but we know our area. So if you think about this, you know the area is 0.15. Yeah. So we can't run it through this because you have two unknowns. So we can't use this any further. But what we could do is we know area is 0.15 and we know this is on the negative side. So if I go to my table and look for that on the negative side, and I want to look for 0.15. Okay, here's 0.15s. 0.15s. Is this as close as we get? right in here, right? 0.15 would be in here. There's 14, think of years like 1492, 1493, 94, 95, and then 1500, 0.15, 1500, 51, all the way to 15 to 1513, 1514, 15. Yeah, so 0.15 is falls in between here. Okay. So then where are we at? Let's see. What is that? Right here, negative 0.1. Okay, so let me write that down. Negative 1.0. 1515, right? 1515. And 1492. Right? Okay, and then what are the numbers at the top? At the top. See these at the top here? So that's 3, negative 0.03, and negative 0.04. And your table probably doesn't have any negatives. I wrote these in. I mean, if these are negative, these are understood to be negative, so I like to write those in. But we're looking at negative 0.03, and that's negative 0.04. See that? Okay. All right. Okay. We're using a table first, and then I'll find it using the calculator, the inverse norm in a little bit. But let me do it on the table first. All right. So now I need to subtract. Remember, it's absolute value area minus potential. And if you take a physics class or chemistry, you have to find distances, and they use this absolute value distances. So area, we're trying to look for 0.15. And then we're gonna subtract. We're gonna subtract. So the potentials are 0.1515 and 0.1492. So you're subtracting one here. It doesn't matter which one you do first, but these are the ones you're subtracting that from. And remember in the other video, I like to use this a little basic calculator, because the graphing calculator gives me scientific notation. And so if you have a little basic calculator, I like to use that here. So this is 0.15 minus 0.1515. And you see that's a negative 0.0015, which is negative, which is going to be positive, sorry. When you take the absolute value of that, it's positive. Take the absolute value of that. Okay, and then this one is 0.15 minus 0.1492, which is 0.0008. I didn't have to write that again. It's the same. All right. Okay, and now if I compare tens place, they're the same. Tens place, they're the same. I mean, ones place are the same. Tens place, they're the same. Hundreds place, they're the same. Thousands place, they're different. Thousands place, we have a 0. Thousands place, we have a 1. So 0 and 1. Okay. So this one has a smaller distance, because 0 is smaller than that 1. So that has a smaller distance. Okay. Yeah. And so again, I like to use this, a basic calculator, because I believe when I use the graphing calculator, if I do 0.15 on the graphing calculator, take away 0.1515. Okay, that didn't give me scientific notation. Okay, and I just had to take the absolute value of that, which gave me this. Okay, let me do the other one. 0.15 minus 0.1492. Oh yeah. See how that one gave you scientific notation? See that? 8e to negative 4. So that one gave you 8e to negative 4, which means 8 times 10 to negative 4, which means move this to the left 4 times, and that counts as one move. So you have 1, 2, 3, 4. Okay. All right. Okie doke. So yeah, so it gets back to that. So I just like to use a basic calculator because I don't have to run into changing it from scientific to standard, right? Okay. All right. But if all you have is the graphing calculator, then it's fine. Do that and fix it. Okay. All right. So now, so we are interested in this one because it's smaller distance. So you backtrack to the 1492 and you backtrack to the 1492 here. And then you backtrack to that relevant Z. And that's the Z you want to go with. You want to go with the Z that gives you the negative 1.0 plus that negative 0.04, which means Z is negative 1.04. Okay, and if I check that on the calculator, the negative, the negative 1.0 plus the negative 0.04 gives me negative 1.04. Okay. 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 Now let me find Z instead of using the table. Now let me find Z using the calculator. Okay, so remember if I go back to my 6.1 lesson, like the last page, remember the last page we did in the 6.1 lesson? Remember sometimes the areas are, see like this one, this was a smaller area, and sometimes the areas are equal, remember? If they're equal, you have to find the average of the two Z's, remember? Okay, remember at the end, we also did the calculator, remember? And we did the inverse norm. So that's what I'm going to do now. We did the table first, and they didn't come out the same distances. One was smaller than the other. So we backtrack, but now I'm going to use the calculator, and it's 3. This is now the formula for that. Not 2 anymore, not 2 normal anymore. It's 3 inverse norm, area, mu, and sigma. And the area has to be to the left of the curve. When you use this area is understood to be to the left of your I'm going to say area to the left, area to the left, area to the left. So this is this right here. It's 0.15. Area to left is 0.15. 15% is 0.15. And mu is 0 and sigma is 1. Okay, so when I do that, and so when I do that, I have second vars, and I want number 3. So I still have to use second vars to get to it. But number 3, and area is 0.15, and then 0 and 1. And we get negative 1.0364, and a whole bunch of other numbers. But z's are hundreds place, tens, hundred. You look at the number to the right. Is that 5 or more? Yep. So add 1 to that. So z is about negative 1.04. So you see this, so we got the same thing. This is using the table and this is using the calculator. Okay. All right. Now, um, yeah, and then just the other thing too is to point out, like earlier when we did the first couple of problems earlier, you know, earlier we had to use earlier we had, when we did like the first problem, we used z, we had to run it through, because remember we didn't know the area. Remember, we didn't know the area, and so we had to run it through. And remember, we knew sigma, right? But we didn't know the area. So that's how that those previous ones from our workbook were different today from what we're doing right now, because this one, um, we can't run it through this because we don't know sigma. So you can't run it with two unknowns. But then how, and then besides, they want you to find sigma, they want you to find standard deviation, which is sigma. So we got to find z, and then we can find that. So that's what I'm trying to do. I'm trying to find z. And I can, because I do know the area. If I know the area, I can do that. I can look for the area using the table. Where is it at between these two numbers? Where is it smaller distance? It's closer to the smaller distance. This is closer to the smallest distance. Or on the calculator, inverse norm. Okay, so then now I can find, now I can go back to this formula, z equals x minus mu divided by sigma. And now I know z is negative 1.04. And I know x was 200 cents. Take away mu was 236.5 cents. And then so 200 minus 236.5 is this, negative 36.5 over sigma. And then to find sigma, I can just cross multiply, right? Like that. There's like an imaginary 1 underneath here. So this is negative 1.04 times sigma equals 1 times negative 36.5. And to find sigma, if I'm solving this for sigma, I'm solving this for sigma, I'm just going to divide both of them by negative 1.04. So I have negative 36.5 divided by negative 1.04. And it gives us 35.09615,385. And as far as rounding sigma, usually the mean and the sigma, right, are in the same, usually mean and sigma are like the same place value digits. And I can also work backwards if I look at the answer key in the book. Let's see, this one was number 12. This was number 12. They rounded out to nearest tenths, 35.1 cents. They rounded to nearest tenths. So they rounded the sigma to nearest tenths because over here sigma and mu, because mu was in the tenths. So they kept these in the same place value. Is what they did. So this would be tenths right here. Look at the number to the right. Is that 5 or more? Yep, that's a 9. So you're going to have to add 1 to that. So it's 35.1 and then it's cents. Okay. Okay, and then there was one last page from your workbook. Page 149. All right, now these are the ones where you're going to use that formula from the very first page. Remember the very first page? I said, remember this formula that what x is equal to. Remember, x is equal to z times sigma plus mu. We're gonna be trying to solve for x, and so we're gonna need to use that formula, and we're also going to be finding z, and they're going to be giving us the percentages, the areas, so we can use the inverse norm formula for that. And then also look for that on the table. Yeah, okay. All right. So now the thing is on the first problem, I did this on purpose. So when I showed that handout from 6.1, this one, the reason why this is a really good example to show me and start off with, because I was going to use it to work this problem from the workbook that we're looking at. Because see, this is us trying to find the z for an area that's zero point 0.9. So we have zero point 0.9 mu. I put mu 0, sigma 1, but we're trying to find this area to the left of the curve. And so zero point 0.9 on the table was between these two values on our table and between these two z's. So we had to find which one was the smaller distance. So remember, we subtracted area minus potential. Area is zero point 0.9 minus these two potentials. And then I was using a graphing calculator here. And it's usually just use a basic calculator so you don't get that scientific notation. But you can see here that this one, this 0 was smaller than that 1. So this one was smaller. So that's why we backtrack to this, we backtrack to that, backtrack to 1.28. And that's what Z is. See right here? 1.28. We're going to use that for this. We're going to use that for this problem. Okay. So I did that to save some time. And so the problem says that to qualify for a police academy, candidates must score in the top 10%. Okay. Okay, so you know the whole graph is 100%. When we say the top 10%, we can do something like this. This is what we're looking at here. And this is reflective of the top 10%. And you know percent is parts per 100. So you know that would give you 0.1. And you divide 10 divided by 100 is 0.1. Okay. And it's because remember the whole graph underneath the curve is 100%, right? The whole area underneath the whole curve is 100%, right? And so you want the top 10%. And so the thing is that if this is 10%, then this area here is going to have to be 100% minus 10%, which is 90%, which is 0.9. Okay, and that's reflective of this, see? That's reflective of this. Okay. And so and it says the test has a mean of 200 and a standard deviation of 20. And it says, let me make this bigger. Find the lowest possible score. So find this lowest possible score. It should be right here. To qualify, for them to qualify, assume the test scores are normally distributed. Okay. So we're going to have to use this formula. X is equal to Z times sigma plus mu. And we know sigma is 20 and we know mu is 200, but we don't know what Z is. So for Z, we can use that 6.1 handout that we just showed you. And we can also use the table method, or you can use the Z equals 3 inverse norm area mu sigma, which is what we did on that handout. And we found Z to equal 1.28 for that area 0.9. So we're not going to show you all that again. That was the purpose of me doing that here to save time. And we said the area, excuse me, the Z was 1.28. So now I can substitute that. X is equal to 1.28 times sigma, which is 20, plus mu, which is 200. And I just type that into my calculator. So I have 1.28 times 20 plus 200. And it gives me 225.6. 225.6. And the thing is, since this is a test score, what they usually do is they would usually round to the nearest whole, round to the nearest whole test score is usually what happens. So if I box this 5 and look at the number to the right, is that 5 or more? Yep, that's a 6. So add 1 to that. So X is about 226. And that's your cutoff. That's your cutoff. Lowest possible score. Yeah, so if somebody makes 225, they won't get accepted. It has to be 226 or higher. And that's this right here. Okay, and then there's one more example like that at the bottom here, but this one's got symmetry. Symmetry. Systolic blood pressure. For a medical study, a researcher wishes to select people in the middle 60%. 60%. So you have something like this going on. Okay. And there's symmetry here. So we're looking at this 60%. And the thing is, if this is 60%, this is symmetry. This is 30 and 30. Middle, 60% of the population based on blood pressure. And so the keyword is middle. Keyword is middle. And the whole curve is 100%. So you already have 100%. Take away 60% leaves you with 40%, but there's symmetry. So you divide it by 2, and now you got 20%. So you got 20% on this side and 20% on this side. And that gives you a total of 100%. Okay. So then, so I did 100 minus 60, which was 40, and then I did 40 divided by 2, which is 20. So how I got that. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and the lower readings that would qualify people to participate in the study. So this is X sub 1 and X sub 2. Okay. Okay. And so I'm going to, let's see. Yeah. So again, the reason why I can't start with this formula like I did on the other problems, the reason why I can't start with that is because see, I don't have x. See, you need for this formula, you need x's, x minus mu divided by sigma. And you see, we don't have our x's, see? We don't know our x's. So that's how come I can't run it through this formula if I don't know my x's. Got to find that. Okay, so what I've got to do is I'm going to have to use, let me see. I'm going to have to make use of this formula. I'm going to have to use x, well, there's two of them. X1 equals Z1 times sigma plus mu. And that stems from x equals Z times sigma plus mu. That's stems from that. And that we did derive on the first page of this sheet today. We did derive that. See here, x equals z times sigma plus mu. So that's what I'm using. But I have two of them. I have to find both of them. So I have to find x1. I put little subscripts of 1 here. And x1 is equal to, so I don't know what z is. I've got to find z. But I do know sigma's 8 and I do know mu is 120, right? Do know that. Okay, but I've got to find z1. Okay, got to find z1. Okay, so find z1 and I'm going to use the table method first and then I'll go back and use the calculator on that. So I'm going to find the table first. So I have my area. And remember the area is to the left of the curve. So remember I'm focusing on this area to the left of the curve. Okay, and which is 20%, you know, 20 divided by 100, which is 0.2, right? That's 20%. It's 0.2. So I'm trying to find 0.2 or 0.20, okay? Or you can say 0.2000. I'm trying to find 0.2. And I'm on the negative side on the negative side because I'm to the left. So I'm going to look up on the negative side and I'm trying to find 0.2. Okay, here's some 0.2s. Here we go. I went like 0.2000. So wouldn't it be between these two? Wouldn't, like, think of the year 2000. Like think of it as years. Think of it as years. The year 2000 is between 2005 and 1977, right? Think of it as a year 2000 and that's between 2005 and 1977. Just think of it that way. And so when I do that, so it looks like it's, see this negative, this is 0.05 and negative 0.04. And then we want these 1977 to 2005. And this is negative 0.8. Okay. All right. So if I jot that down, negative 0.8, 0.2005. 1977. And then this is negative 0.05 and negative 0.04, right? Okay. Okay, now you're going to try and see which area is which distance is the closest. So I'm going to do that formula where I do area minus potential. So the area we're looking for is 0.2. I don't know the zeros. And we're going to subtract. And I'm going to subtract. It doesn't matter which one first, but the potentials. And then I like to use the little basic calculator because it's gives me scientific notation on the other one. This saves me a step. So if I do 0.2, take away 0.2005, absolute value of that, and then 0.2, take away 0.1977. Okay, so in the ones place they're the same. In the tens place they're the same. Hundreds are the same. Thousands are different. So here and here. Okay. So this one's the smaller distance. That's a smaller distance. Okay. And that's a smaller distance. And so when you backtrack, smaller distance, when you backtrack, you're backtracking to this, backtracking to this, backtracking to this Z right here. And so we're looking at, you're going to use or go with the Z that's got the negative 0.8 plus the negative 0.04, which should give you negative 0.84. Okay. Yeah, and if you add those, that if you add this and this, negative 0.8 plus negative 0.04, it gives you, see, negative 0.84. Okay, now on the calculator, finding on the graphing calculator, on the TI-84, using Z is equal to number 3, inverse norm, area, mu, and sigma. And area is the 0.2. So area has to be to the, remember we said area has to be to the left of the curve. So that would be 0.2 or 0.20. Mu is 0, sigma is 1. So when you do the second vars, number 3, and then 0.201. You have negative 0.8416212, and so on and so on. And we want a z. Z's are in the hundreds. So you box the 4. Look at the number to the right. Is that 5 or more? Nah. So you have about, z is about negative 0.84, which is what we got over here using the table. So now you can go back to this formula. Now you know z is negative 0.84 times 8 plus 120. Okay. So now we go back here and we have negative 0.84 times 8 plus 120. And that gives you 113.28. And that's just for x1. We still got to find x2. But x2 will be easier because there's symmetry. There's symmetry. So you see, when you find x sub 2, you're going to run it through this formula. And you know sigma is 8 and mu is 120, but you got to find the other z sub 2. But you don't have to go through all this drama here. Because there's symmetry, the other z sub 2 is its absolute value because there's symmetry. So the absolute value of negative 0.84 is positive 0.84. And so you run this formula again with this being positive, and then you'll find your x sub 2. So thank goodness there's symmetry. That's what allows you to do that. Now, I'm not sure where I'm going to write that because I don't really have too much room, but I guess I can squeeze that here. And I can say to find the second z2, to find z sub 2, you're going to use symmetry. And you're going to take the absolute value of z1, which was the negative 0.84. So the absolute value of negative 0.84 is just 0.84, and that's going to be what z2 is because there's symmetry. So now you're going to use the formula x is equal to, or x sub 2 is equal to z sub 2 times sigma plus mu. So x sub 2 is equal, now you know z is just a positive 0.84, and you know sigma is 8 plus mu, and the mu is 120. So on the calculator, I'm going to do that. 0.84 times 8 plus 120 gives me 126.72. Okay, and then there was one last idea I was going to share with you. So remember I said I don't make use of 150 and 151. I think that's just extra fluff that's in there. I don't think we don't need that for the problems that we're doing. But I was looking at, I believe in your homeworks and in the ebook, there was one more that I wanted to coach you on. Let's see if I can find it. And it was 31, I believe it was 31A. go. It was 31A in the ebook. Make sure there wasn't anything else. I think. Yeah, let's look at 31A. That'd be the last one. Oh, so 31A looks like this. Look at that. A, B, C. Okay, we're gonna do one part. We're gonna do part A, and B and C would be similar. But let's look at A. So it says that in the distribution shown, they want you to state the mean. Okay, so that would be like here for this one, 120. And then they want this, and they want the standard deviation for each. And it says, hint, think of your figure 6.4 and 6.6. And I'm going to sketch that in a little bit. I think, let's see. I'll have to get the ebook out. Also, the vertical lines are 1 standard deviation apart. Okay, so we'll keep that in mind. And then they have little answers there. Okay, so I did sketch out figure 6.4 and 6.6. So I do have a figure here of 6.4. Okay, so I have a note here that we need to recall. I have here from page 307 from chapter 6, section 1. I have this picture. Let's see. And I have mean. And then I have this here as mu minus 1 times sigma. And then mu plus 1 times sigma. And then I have here 68%. So I have here 34%, 34%. And that's where I get the 68% for that, approximately. And then I also have mu plus or minus k times sigma. And then I have over here that k is 1. K is 1 here. K is 1 there. Okay. And then I have these are supposed to all be, these are all supposed to be, recall page 507. These are all supposed to be figures 6.4 and figures 6.6. And this is also on page not only 307, but it looks like 306 as well. And then I have this other figure. Let me see. So I have here 0, -1, 1, +1. And then I also have 34%, 34%, and then 68%. Okay, and then I make use of the problem in the book. The book, I'm gonna get the picture from the book, 31A. So let's see. Okay, so let me see. I'm gonna sketch what the book. I'm not gonna sketch all the lines. I'm gonna do this. So we got the mean. Remember, I said the mean was 120. Remember, I set that right away when we saw this. Remember, said that's 120, and then I have here 100, and then here I have 140. So those I'm getting from here. See, 100 and 140. Now I don't really need all the other ones. And then I have note the vertical lines are 1 standard deviation apart. Yeah, I think I read that right in the readings. I think it said that vertical lines are 1 standard deviation apart. Okay, so I've got that. And what did they want you to find? They wanted you to find, they want you to state the mean and state the standard deviation. Okay, so the mean's easy. The mean is mu, which is for, we're doing part A is 120. That's the easy part. But then the standard deviation, to find the standard deviation, which is your sigma, we're going to use the formula um, mu plus 1 times sigma equals 140. Or you can use mu minus 1 times sigma equals 100. So let's see where we got those from. So you see, I'm setting this equal to 140 because of this. And this one I'm setting equal to 100 because of that. And this one I have the positive because it's on the right side of the mean, mu plus 1 times sigma. And this one I have the minus because it's on the left side of the mean, mu minus 1 times sigma. And I'm getting the ones because they said that the vertical lines, these vertical lines are 1 standard deviation apart. And so then I knew this was related to the one sigma here. See that? And yeah, and so there's your, you see mu plus 1 times sigma. And that's coming together, right? Mu plus or minus k times sigma. So I'm trying to find the standard deviation, but I know the mean. Remember, we're going to let mean equal 120. So we're going to let mean equal 120. So if I substitute here 120, mu is 120. So if I substitute 120 minus 1 times sigma equals 100. And so that gives me 120 minus sigma equals 100. And then I'm going to subtract 120 on both sides. This falls out. So minus sigma equals 100 minus 120 is a negative 20. And then I just divide both sides by negative 1. And sigma equals negative divided by negative is a positive. And I should get the same thing over here on this side. If I let mu be 120, I have 120 plus 1 times sigma equals 140. And then I subtract 120 on both sides. So then this falls out. So I have 1 times sigma equals 140 minus 120 is 20. And so sigma is just equal to 20. And that's what the sigma equals for the part A. And then you would do the same thing for part B and part C. So you're just changing here. The mean changes here to 15. And then the mean changes here to 30. But, and then of course the 140 would change, of course, to this 17.5 and 12.5. But other than that, you would still use this formula here. So the idea is you're using mu plus or minus k times sigma, and that equals like your x, right, your data value. Okay, that equals your x, your data value. Okay. Okay, so that should help you with your homework when you work on those. And then you just want to make sure you keep up with your homeworks. If you have trouble, you want to make sure you have time to go to Math Row and see our go-to tutor, Trudy. Trudy, and then there's another a lady that works at night in the evening shift. I can't remember her name. I think it starts with a D, but I just can't remember. But they have their who are assigned the stats tutors there on the list. But you don't want to get behind on your homeworks, because we need to get ready to take this last test, and then there's a last quiz number 3, and then the final exam. And so you got to pull it through, and don't get behind on your homework, because the last day to draw has already passed, so nobody can withdraw, at this point, if the last day has passed for any reason. But you got to make sure you finish your homework to be eligible to take your tests. So this is one of the more time consuming sections. And so if you need help, please go into Math Row to see Trudy, or the other lady that teaches at night. I'm sorry, I can't remember her name offhand right now. But get your homeworks done, okay? So we have the 6-2 and then the 6-3 to work on, and then we want to take the test. All right. So good luck with that. Okay. Take care.